Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. So, I am welcoming you all to this beautiful online learning platform once again. We are happy to announce that now Unacademy is going to providing training for GATE and engineering service exams with India's top educators. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE exam. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, first we check how to get Unacademy learning app. So to get this app, just go to Play Store, type Unacademy in that, type Unacademy, and just click on this install button. It will install the Unacademy learning app into your device. Now, so what you will get by joining Unacademy, what you are going to be getting. Now, first and foremost important thing is by joining in this, you are going to be getting daily live classes. In that live classes, you can chat with your educator, you can engage the discussions, and so you can ask your doubts to your faculty and answer the polls, answer the polls. Now while class is going on, faculty will ask some of the questions and they will conduct the polls, so you can participate in that. Now, so these are the first and foremost important point in this. Next, structured courses. So in this, all your courses are structured in line with your exam syllabus to help you best prepare for it. So for best preparation of that, first you should know what is prepare first, what next. That sequence is very important, that line of sequence. Okay, so here you are going to getting that. Okay, what are this series syllabus, exam syllabus you have, that is going to be structured in a proper order. And third one is live tests and quizzes. They are going to be conducting exams. More number of tests you have to be write, because to evaluate your preparation, you can evaluate your preparation with your regular mock tests and quizzes and get the detailed analysis on your performance. This is very important. After this, getting all this is very important. Okay, so evaluating the performance, evaluation of your preparation with exams, and after that analyzing your performance is very important thing. Next, unlimited access. It means once you get a subscription or once you take in a subscription, you can access all our live and recorded courses to watch from any comfort of any of your device. Okay, you can watch your comfort, any device, in any device, either mobile, laptop, desktop, okay, or tab, any of your device comfort. So you can watch in that. These are the benefits you are going to be getting by joining Unacademy. Now there are two subscriptions. One is a plus plan, other one is iconic plan. Now first I will show the plus plan. This is about your plus subscription. In plus subscription, daily live classes you have, In that, you can chat with your educator and engage in discussions, ask your doubts, and answer the polls. So all those things you can perform in this. While class is going on, you can perform all this. At the same time, structured courses. Your course is well structured in line with your exam syllabus and live tests and quizzes. Okay, so you can evaluate your preparation with your regular mock tests and quizzes, and after that, get the detailed analysis on your performance and unlimited access. Just before, what are the things I mentioned, all those things you are getting in plus subscription. Okay, now in addition to these all, in iconic subscription, whatever the all benefits you are getting in plus, you are getting all those things, no doubt at all. But in addition to this, we are providing a personal coach to you. We are providing a personal coach to you. Now from that personal coach, you can get, so we are providing a personal coach now on the basis of one-on-one guidance. One-on-one guidance. That means for every individual student, we are providing one personal coach. That personal coach is a top exam expert. That personal coach is top exam expert. Okay. Now, he can, once you've written the exam, he is going to analyze your exam paper, and he will note few points. That means where you are strong, where you need more preparation, where you are doing mistakes. He will collect the total information, and based on that, they will prepare a proper study strategy to you, a proper study plan to you, and they will provide respect to learning resources, respect to study material also they will provide. Okay, next, study tracker. So by to know your progress, you can get that by weekly review with your personal coach. So by participating in study tracker plan and study booster workshops. Okay, so by participating study tracker plan and study booster workshops, so you can evaluate your progress in weekly reviews with the personal coach. And mains question and answer practice. So strengthen your mains answer writing through regular practice with evaluation and personalized feedback. So you can strengthen your answering procedure by practicing more and get the, after once you've written the answer, it is going to be evaluated and they will give the personalized feedback to you. From the knowledge of that, you can strengthen your practice, your question and answer procedure. These are the additional things you are going to be getting by joining iconic subscription with respect to plus. Yeah, so now our today's topic is transistors biasing problems. Last session already we done some problems. These are the problems we done in last session. So in that we observed, first we calculate IC maximum. After that, if IC is less than IC maximum, it means transistor is in active region. If IC is greater than IC maximum, transistor is in saturation region. Okay, yeah. Now I am going to this one. Yes. Now this is our problem. Here, see this, what we have to do, check the region of operation and operating point. They given beta 100, VB 0.7 and VC saturation is 0.2 volts. So for my better understanding purpose, I am taking both the circuits So both the circuits I am taking separately. So this is the circuit. These are the two circuits. Now I am going to analyzing both the circuits. So for that they given beta value 100. Okay, and beta value 100 they given, and VB also they given 0.7. Okay, and VC saturation is they given as 0.2 volts. Similar to the previous procedure, just I am going to calculating first IC saturation or IC maximum value. Okay, now sorry, so this is the problem. So this is here we get VCE, this is IC current, and this is also IC you have to take for VCE saturation. Okay, so just a minute. So for calculating IC maximum, you need to take this is IC maximum. So this is IC maximum. And this is also IC maximum. Okay, this is VCE saturation. First I am calculating the transistor is in saturation or not. That's it. From this I am calculating IC maximum. Just apply KVL to output loop. Okay, now by applying KVL to output loop, you can write applying KVL to output loop, 10 is equals to IC maximum into 2K plus VCE saturation plus IC maximum into 5K. You may ask one thing, sir, it is the emitter. Now the current should be emitter current. Why are you taking IC maximum? See, when you feel your transistor is in saturation region, so the IE is equals to IC maximum. So when you are feeling that your transistor is in saturation, IE is equals to IC maximum. Okay, therefore in saturation, IE equals to IC maximum. IE equals to IC maximum. Now I am simplifying this. So it is a 10 minus VBE, they given it as a, sorry, VCE saturation they given 0.2. Okay, it is our VBE. They given it as a 0.2. VCE saturation is equals to IC saturation into 2K plus, sorry, IC maximum or saturation, both are equal, it's okay. Into 2K plus 5K. Therefore IC maximum is 9.8 by 7K. Now it is approximately 1 point something. So 9.8 divided by 7. So that is 1.4K. 1.4 milliamperes. So this is the IC maximum. Now calculate the IC in this by applying regular procedure. Okay, then get the, compare that IC with this. If this IC is greater than this, then transistor is in saturation. If it is less than that, transistor is in active region. Okay, now So we know that this is going to be VBE and this is emitter current. So now applying KVL to input loop, to calculate IB. So applying KVL to input loop. Just I am applying KVL to input loop. So for that 5.7 equals to VBE plus IE into 5K, and we know IE equals to IB plus IC, and IC is beta times IB. Just substitute this one here. Therefore IE can be written as IB plus IC is beta times IB. So which is 1 plus beta times IB. 1 plus beta times IB. Take this substitute here. Now 5.7 minus VBE value. Take this VBE this side. Is equals to IE is 1 plus beta times IB into 5K. From this 5.7 minus 0.7 by K equals to 1 plus beta. 1 plus beta is 100 into 5K into IB. Therefore IB is 5 by 101 into 5, 505K. Now how much it is? That is 9.9 microamperes. 9.9 microamperes. That is IB value. Now IC is, we know that beta times IB. Beta times IB. So it is beta is given as 100 into 9.9 micro into 100. It is 0.99. 0.99. See, this is a 9.9 micro. Okay, so it is a 9.9 into 10 power minus 4. So which is 0.99 milliamperes. That is IC. Okay, now but IC maximum is 1.4 milliamperes. Therefore IC is less than IC maximum. Therefore transistor is in active region. Is in active region. That's it, simple. Okay, now so this transistor is in active region. After this, so IC is calculated. Now we need to calculate IE as well as VCE, because our intention is to calculate operating point also. We need to calculate. So for that I am copying this circuit to apply KVL to output loop. Just I am copying this circuit. Yeah. Now see this, just before we calculated IC, that is 0.99 milliamperes. So IE is 1 plus beta times IB. So 1 plus 100 into IB. IB value is, we calculated already, it is 9.9 microamperes. 9.9 microamperes. So it is 9.9 into 101. That is 999.9 micro amperes. It is 0.999 milliamperes. So you can take it approximately 1 milliampere. 1 milliamp IE. This is IE. Now applying KVL to output loop to calculate VCE. Therefore, KVL to output loop. I am applying KVL to output loop. Up to ground. Now here power supply is 10 volts. So 10 is equals to IC into 2 kilo ohms plus VCE plus IE into 5 kilo ohms. Now VCE is 10 minus IC into 2K minus IE into 5K. Now therefore 10 minus IC value 0.99 milli into 2K minus IE value 1 milli into 5K. So it is 10 minus 2 into 0.99, that is 1.98 volts, minus 1 milli into 5K is 5. So now it is 3.02 volts. Therefore operating point is VCE comma IC, which is 3.02 volts comma IC value 0.99 milliamperes. This is the procedure to calculate your transistor is operating in which region as well as operating point of the transistor. This is the second part in that. Same thing, but resistance at emitter is decreased from 5K to 1K. Okay, now first I am going to calculating its IC maximum from this. So I am copying this, another one for regular class, regular calculation. So this is IC VCE saturation. Now in saturation we know that emitter current is IC maximum or IC saturation. Okay, now this is IC saturation. Similarly, it is also IC saturation because it is emitter current equals to IC saturation. Now apply KVL to output loop. So by applying KVL to output loop, we get it as 10 equals to IC saturation into 2 kilo ohms plus VCE saturation plus IC saturation into 1 kilo ohm. From this, IC saturation is 10 minus VCE saturation by 1K plus 2K, 2K plus 1K. So now it is 10 minus VCE saturation given as 0.2 volts by 3 kilo ohms. So it is 9.8 by 3 kilo ohms. So 9.8 divided by 3. That is 3.26 milliamperes. So this is the IC saturation. Now just calculate the IC value for that circuit. If IC is greater than this IC maximum, greater than or equal to this maximum, then your transistor is in saturation region. So for that, in that procedure, first you need to calculate IB, and they given VBE value 0.7, and the current through this one is IE, and we know that IE is 1 plus beta times IB. Just using these relations. Now applying KVL to input loop to calculate IB. So applying KVL to input loop. So 5.7 equals to VBE plus IE into 1 kilo ohm. Now IE 5.7 minus VBE is equals to, IE is nothing but a 1 plus beta times IB into 1K. Okay. Now from this, IB is 5.7 minus 0.7 by 1 plus 100 into 1K. So it is 5 by 101K. So from this, IB is 5 by 101, that is 49.5 microamperes. 5 microamperes. That is IB value. Now IC is beta times IB. So beta is 100 into 49.5 micro. So 49.5 into 5 micro. So it is 49.5 into 10 power minus 4 amperes. That is 4.95 milliamperes IC. So from this we can conclude that therefore IC is, see carefully, IC, this is our IC, this is IC maximum, IC is greater than IC maximum, therefore IC is greater than IC maximum. So once IC is greater than IC maximum, transistor is in saturation region, therefore transistor is in saturation region. That's it. Okay, now so once it is saturation region, operating point is, therefore its operating point is VCE saturation comma IC saturation. IC saturation. So that is a 0.2 volts comma 3.26 milliamperes. That's it. Okay, now I'm going back. So this is in saturation region. So here what we get, see carefully, the difference is 5.7 volts, 5.7 volts, 10 volts, 10 volts, 2 kilo ohms RC, 2 kilo ohms RC. But in case of RE, it is 5 kilo ohms, it is 1 kilo ohm. Here is the difference. RE value is differ from both the circuits. So previously we observed by increasing the RC value, transistor is switching from active to saturation region. Now, but in case of emitter resistance, by decreasing the emitter resistance value, transistor is switching from active to saturation. So therefore, by decreasing the emitter resistance value, the emitter resistance value, RE value, transistor can be switched from active region to saturation region. Active region to saturation region. Okay, so my dear students, not only solving the problem, after completion of the solution, you need to conclude that, give some conclusion. So for that purpose only I placed these two circuits simultaneously. Okay, I kept these two circuits in a single problem. Is it okay? Yeah. So now we are moving to next problem. You see this, the same thing here. Same circuit, calculate all node voltages and branch currents. They want voltages and branch currents. They are not asking any region of operation, anything. Okay, now first I am taking this circuit. Both are different circuits. And they given VBE value and VBE mod VBE means this is PNP transistor, not NPN. So between base to emitter or emitter to base voltage is 0.7 volts and beta is 100. That is the meaning of that. Now see this. So they given this one. This one to this voltage is 0.7 volts. And this is the connected to base terminal. So this is base current and this is emitter current. Because it is PNP transistor, it is collector current. This is base current IB. Okay, and this is the voltage VEC. VEC. Okay, now they want all terminal voltages and currents, all node voltages and all terminal currents and possible voltages. Just I am applying KVL to input loop. So just I am applying KVL to input loop. See this? Now by applying KVL to input loop, what we get? 1.4 volts equals to 0.7 plus IB into 70K. Therefore IB is 1.4 minus 0.7, 0.7 by 70K. So which is 0.1 by 10K. Okay, now this is 100, 10 by 1000, 10 by 1000K. So this is 10 microamperes. IB is 10 microamperes. And the given beta is 100. So mod VBE they given 10, sorry 0.7 volts. This is the given data. Now just I am going to IC value. IC is beta times IB. 100 into 10 micro, that is 1 milliamp, 1 milliamperes. Similarly I am calculating IE. 1 plus beta times IB, that is 101 into 10 micro, that is 1.01 milliamperes. Okay, IE calculated. Now I am going to VEC. To calculate that, just apply KVL to output loop. Just applying KVL to output loop. Okay, now KVL to output loop. So in this 1.4 equals to, so there is no resistor at emitter terminal, so no need to write, or otherwise you can write 0 into IE plus VEC plus IC into 5 kilo ohms plus minus 5 volts, collector connected to minus 5 volts, minus 5. Now simplify this, take this one this side. Now it is a 6.4, it is 0. Therefore VEC equals to 6.4 minus IC into 5K, that is 6.4 minus IC value is 1 milli into 5K, that is 6.4 minus 5, so it is 1.4 volts. That's it. These are the all possible currents and voltages. Next, taking this circuit, same procedure, just they given VEB 0.7 volts and beta also they given 100. This is, now there is no base resistance. Now here is a resistance they given, it is emitter terminal, so it is IE, it is collector terminal, so it is collector current IC. Okay, now I am going, and this is the voltage VEC. Just applying KVL to input loop to calculate base current. That's it. Now just we applied KVL to input loop. So 10 equals to IE into 2K plus 0.7 plus 0 because base connected to ground. From this directly we get IE, therefore IE is 10 minus 0.7 by 2k. 9.3 by 2k. Okay, now so 9.3 divided by 2, 4.65 milliamperes. That is IE. Next, I am going to calculating IB. So we know IB is we know this one, IE equals to 1 plus beta times IB. From this we can write IB is IE by 1 plus beta, simple. IE by 1 plus beta. So 4.65 milli by 1 plus 100, 101. That is 4.65 milli by 101. So that is a 46.03 microamperes. 46.03 microamperes. That is IB. Now I am going to IC. IC is beta times IB. So beta is 100 into 46.03. Okay, so it is micro. Now it is 4.603 milliamperes. Okay, so once you know IC, IE and IB, just apply KVL to output loop. Now applying KVL to output loop. So 10 equals to IE into 2K plus VEC plus IC into 1K plus minus 10 volts. Now take this minus 10 this side, it is a 20. Now VEC equals to 20 minus IC into 1K minus IE into 2K. IE into 2K. Now 20 minus IC value 4.603 milli into 1K minus IE value 4.65 milli into 2K. 20 minus 4.603 minus 9.3, it is 9.3, 4.65 into 2, yeah, 9.3. Okay, plus 4.603, 13.903 minus 20, yeah, it is 6.09, 6.097 volts. So this is the value of VEC. So therefore VEC is 6.097 volts. Okay, this is the procedure to calculate the required terminal currents and voltages for PNP transistor. Okay, so far we done and we calculate everything for NPN transistor as well as PNP transistor. Okay, next one. So next problem. Now we are going to next one. Yeah, this is the circuit they given, PNP transistor. Already we done this type of model in previous. So we need to calculate VEC. So they given plus minus VBE. That means mod VBE means VEB they given for PNP. For NPN you can use 0.6 VBE. So 0.6 volts it is. And this is the IB current. First basic things, these are the things. And this is the collector terminal, so it is IC. This is emitter terminal, so this current is IA. Okay, even though not resistor is no resistor is there, current is IA. This is the VEVC. It is the voltage between emitter to collector, VEC, which is voltage at emitter minus voltage at collector. We need to calculate this. But voltage at emitter is nothing but a 3 volts. It is connected to this. So it is 3 volts minus VC, voltage at collector. This is voltage at emitter. This is voltage at collector. What is voltage at collector? It is IC into 500 ohms. Because this is the collector terminal. I want voltage at this point, that is VC. Okay, voltage at this point V is equals to IR. So IC into 500 ohms. So it is 3 minus IC into 500 ohms. Just you need to calculate IC value. That's it. To calculate that, first I am applying KVL to input loop. So KVL to input loop to calculate IB. So now 3 equals to here no resistor. So 0 into IA plus 0.6 plus IB into 60 kilo ohms. Now from this IB is 3 minus 0.6 by 60k is 2.4 by 60k. That is 0.04 by 4 milliamperes or 40 microamperes. That is the IB. Now I am calculating IC. Therefore IC is beta times IB. The given beta is 50. 50 into 40 micro. That is 2000 micro amperes. It is nothing but a 2 milliamperes. Therefore VC is IC into 500. 2 milli into 500. It is 1 volt. 1 volt. Now it is 3 minus 1 volt. Okay, 3 minus 1, it is 2 volts. That is the answer. So we need VEC. So we got VEC is it is mod, sir, mod. So here is a mod VEC. Okay, so it is 2 volts. Like this you have to solve the problems. Next one, see this. So consider the circuit shown in figure, assuming VBE1 equals to VBE2 equals to 0.7. That means this is transistor Q1 and its value is 0.7. Similarly this value also 0.7 volts. Fine. Value of DC voltage VC2 in volts. So they want this voltage, how much it is voltage. Now if you observe one thing, this is the second transistor, emitter terminal, base terminal, and it is collector terminal. Now this is PNP transistor. So this current is IE2. This current is IB2 and this current is IC2. The required value is VC2. Therefore, VC2 required VC2 is 1 kilo ohm into IC2. So now your intention is to calculate IC2, but they given the beta value. Beta 1 is 100 and sorry, this is beta 2. Beta 1 is 100 and beta 2 is 50 they given. Therefore, we can write IC2 is beta 2 into IB2, because IC is beta times IB. So beta 2 times IB2. So we know beta 2, they given 50 into IB2. Take this one, substitute here. Therefore, VC2 is IC2 is 50 into IB2 into 1K. Now it is IB2 into 50K. Just to get the value of IB2, substitute here, then you get the VC2. To get IB2, we need to apply KVL from supply to ground. Now, which direction you need to go for it? Now that is the problem issue here. See, to go for this side, this is one option. From here, 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 here. This is one option, like this. And another option is this one. Go like this. Here, the problem is, in this, if you move, for moving this side, the problem is, we don't know the value of VCE1. Okay. Now, we can move easily this direction. Why? Because we know supply voltage VCC 2.5 volts here, and after that the voltage between base to emitter is 0.7, and between emitter to base VEB for PNP is 0.7, and here voltage is 10K into IB2, and here potential 1 volt connected to ground. Now I am going to taking that path. So this is the path I am going to be taking. So path selection is very, very important, sir. So you need to practice that. Now from emitter, I'm going like this. Like this. This is the path I am choosing. Now applying KVL to this path. So applying KVL. So VCC is 2.5 equals to 0.7 plus 0.7 plus 10K into IB2 into 10K plus 1 volt 0. Now it is 1.4 and it is 2.4. Now IB2 is 2.5 minus 2.4 by 10K. That is 0.1 by 8. Then 50% of your problem will be completed there itself. Okay. Next. Okay. Now see this. Find the operating point of this circuit. Beta is 50 and VB is 0.66. Now once they given the circuit like this, We are doing operating point. Our intention is to calculate operating point. Calculation of operating point comes under DC analysis. Therefore, calculation of operating point is comes under DC analysis. Comes under DC analysis. For DC supply, so for DC or in DC analysis, capacitor is open circuited. Therefore, in DC analysis, capacitor is open circuited. Okay, now first you need to take DC equivalent circuit of the given circuit. Okay, DC equivalent circuit of the given circuit you need to take. That is our first requirement. So for DC equivalent, we don't want these values. We don't want this. Now I am going to removing this. So we don't want this one also. See, we don't want this capacitor because this capacitor is open circuited. It is also open circuited. Once these two capacitors are open circuited, now the equivalent circuit is like this. So this is the DC equivalent circuit. Therefore, DC equivalent circuit is shown below, and its values are so it is 10k 10k. So this is a 10k and it is also 10k. For my better understanding purpose, let us I am taking it as R1 and it is R2, it is RC and it is RE. Okay, now this is nothing but our self bias circuit, and they given VBE also, that is 0.66 volts. I think so, yeah, 0.66, and beta is 50 they given, and they given beta is 50. So you need to calculate operating point of this circuit. So to calculate operating point, first you need to take its equivalent circuit by applying Thevenin's theorem at input side. Now I am taking its Thevenin's equivalent at input. So already we done this total analysis in self bias. This is the next level of circuit. It is plus VCC, RC, RE, VBE, RB, VBB, and RB is R1 parallel with R2, that is 10 kilo ohm parallel with 5 kilo ohm, that is 50 by 15 kilo ohms. Okay, as well as you need to calculate VBB. VBB is 20 volts into, that means VCC into 5 kilo ohms by 5k plus 10k, which is 100 by 15 volts. Get the value. So it is 50 divided by 15, 3.33 kilo ohms. Now it is 100 by 15, 6.66 volts. So this is 6.66 volts, and RB is 3.33 kilo ohms. Okay, now so we know that it is a emitter current, this is collector current. So first, by applying KVL to input loop, we need to calculate IB. So just applying KVL to input loop, and one more, sir, this is base current IB. So just applying KVL to input loop, now 6.66 equals to IB into RB plus VBE plus IERE, and we know that IE value is 1 plus beta times IB. They given beta value 50, so it is 51 IB. Take this one, substitute here, therefore 6.66 minus VBE is equals to IB into RB plus, I am substituting directly this value, 51 times RA. Okay, now IB is, it is a 6.66 minus VB, they given 0.66 by RB, they given RB value, we got 3.33k plus 51 into RE value, they given 10k. So it is 6 by 510, 513.33k. So 6 by 513.33k. So that is 11.6 microamperes. 11.6 microamperes. Okay, now so once IB is there, now we go for IC. So at the same time we go for VCE also. I'm going to copying the circuit once again. This is a VCC. So just before we got IB, that is 11.6 microamperes, and IC is beta times IB. Beta is 50 and IB is 11.6 micro. So 11.6 into 50, that is 580. So 580, that means 0.58 milliamperes. That is IC. And I am going to IE also. IE is 1 plus beta times IB. So that is 1 plus. That means 51 into 11.6 micro. So 51 into 11.6. It is 0.591 milliamperes. Okay, that is IC and IE. Now we need to calculate VCE. For that, just apply KVL to output loop. Applying KVL to output loop. Okay, now here VCC is there. Therefore, I'm applying KVL to output loop. So in that, VCC equals to ICRC plus VCE plus IERE. Therefore, VCE equals to VCC minus ICRC minus IERE. Just substitute values. They given VCC 20 volts minus IC we got 0.58 milli into RC. So RC 10 kilo ohms, RE also 10 kilo ohms, minus IE 0.591 milli into 10k. Here also 10k. Simplify this. 20 minus k milli gets cancelled. It is 5.8 volts minus it is 5.91 volts. So net is total is 5.8 plus 5.8 plus 5.91 much minus 20. That is 8.29 volts. Therefore, operating point VC is 8.29 volts. Therefore, operating point is, our intention is to calculate operating point. Operating point is VCE comma IC, which is 8.29 volts comma IC value is 0.58 milliamperes. That's it. Okay, so like this you have to solve your problems. Now, thanks for spending your valuable time with us. So next session we are going to the remaining problems. So these are the top educators from Unacademy. Tiwari sir, he is IIT topper. He has 7 years of GATE and engineering service teaching experience, and he is the author of the book GATE in 75 days. And Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical, and he was awarded President of India Gold Medal in IIT Indore. And Sanchit Jain sir, he is the computer science faculty. He is having teaching experience of more than 8 years. Jaspal Singh sir, he is ex-IAS officer. Okay, and he got All India 4th rank. And he is the ex-senior faculty from MedEasy. Okay, And here are few more top faculty, top educators from Unacademy, sorry. And here are few more top educators from Unacademy from different departments. Now just we glance what are the different engineering disciplines available in Unacademy for GATE and engineering service exam: electronics and communication engineering, chemical engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. These are the different engineering disciplines. Next, there are two plans. One is plus plan, it is the basic plan. Next, iconic plan, it is the next level of. That means it will take your preparation to the next level by with the personal coach. We are providing a personal coach to each and every student in iconic plan. Now, in both the cases, India's best educators are handling your subjects. Interactive live classes are there, and structured courses and PDFs, live tests and quizzes. Here also live tests and quizzes. Now, here we are going to show the difference between plus plan and iconic plan. So once you write an exam, your exam paper is forwarded to your personal coach. You do the personalized test analysis on that, and based on that they will prepare a proper study planner, and respective material also they will provide to you. By following these, every student can get success in their examinations. Okay, now see, in plus plan there are different subscriptions are available: 1 month subscription, 3 month subscription, 6 months, 1 year, 1.5 year, and 2 years. And at the same time, EMI optionals are available. As a faculty, I recommend the students to take minimum 1 year subscription, because 1 year is required for a student to complete their preparation and write more number of exams and revise the subject more number of time, multiple times. Okay, and identify the gaps in their preparation, and to fulfill that they need minimum of 1 year time. And by using my code VRAO10 during subscription, you get it by a 10% discount. Now it is 27,225 rupees only by using my code VRAO10 during subscription. Okay. Next, iconic plan. We are moving to iconic plan. In iconic plan, two subscriptions are there: 1 year subscription and 2 year subscription. For 1 year subscription, it is 50,250 rupees. By using my code VRAO10 during subscription, 10% reduction you get discount, that is 45,225 rupees only. Okay, so don't forget to use my code VRAO10 during subscription. And so my dear students, outside situation is not good. So day to day COVID cases are increasing. In this pandemic, it is very difficult to moving outside. Please restrict your movement, stay at home, stay safely. And whatever the thing is happened at outside, your learning process cannot stop. So by joining in this, get the more benefits. Now don't forget to use my code VRAO10 during subscription. Subscribers, please give your valuable comments and hit the bell icon for getting notifications, and join our Telegram group for getting latest updates on our upcoming videos. Thank you very much. Thanks for spending your valuable time with us, and once again I am welcoming you all to this beautiful online learning platform, Unacademy. And once we thank the Unacademy for providing such a beautiful environment to share our knowledge. Okay, and it is providing more benefits to the students community. Thank you very much.